In school, we are often told to memorize facts. Wheat grows in temperate climates. Rice needs lots of water. But just knowing a fact isn't engineering. Engineering is taking that fact and turning it into a predictive model. Today at Maker's Place, we are solving the farmer's dilemma. How do we move from guessing to knowing? We aren't just using sensors today, we are developing an autonomous vegetation selector, a logic-based system that processes environmental variables to make real-time agricultural decisions. A sensor by itself is actually quite silly, it just gives us a raw number. The real magic happens in the algorithm. Our problem statement today is how can we translate light and moisture levels into a successful crop recommendation? We need to categorize the world into biomes, rainforests, deserts, and grasslands. But instead of reading about them in a book, we are going to define them using conditional logic. To build this, we first need to understand our hardware. At the heart of the project is our controller. Think of this as the brain. It takes in information from our environment and decides exactly what to do next. Now let's look at the rain sensor. This sensor has a series of exposed copper tracks. When water drops hit it, the resistance changes. But here is a pro tip. This sensor doesn't actually measure the exact amount of rainfall in millimeters. Instead, it gives us a reference value. It tells the controller how much moisture is present, which we then use to trigger our code logic. Next, we have the OLED display module. OLED stands for Organic Light-Emitting Diode. Unlike your TV at home, each tiny pixel here creates its own light. This makes it incredibly sharp and clear, allowing us to read the names of the suggested crops even in low light. Now, let's get everything connected. Grab your cables and follow along. Step 1. Take your rain sensor and connect it to port A on our controller. This port will read the analog moisture values. Step 2. Take your OLED display module and plug it into port D. This is our dedicated communication port for the screen. Step 3. Power up the controller. Since the light sensor is already built in, our hardware setup is complete. Next, let's open the Float app and select our controller to start the project-based coding. First, we need to tell the software what sensors we are using. Go to the input menu and select the light sensor. Next, select our external components, the rain sensor and the OLED display module. Drag them into the workspace and attach them to their respective ports. Remember, rain sensor to port A and OLED to port D. Now let's look at the coding blocks. As you can see on the screen, our program starts with a start block and immediately enters a loop. Inside this loop, we have three main decision branches. Branch 1. The first decision block checks if the light is less than 10 and the rain sensor is between 50 and 100. If this condition is met, the action block tells the OLED to display temperate crops like wheat. Branch 2. If the first condition isn't met, the code moves to the next decision. Is light less than 10 and rain between 25 and 40? If yes, the OLED displays apple. Branch 3, finally it checks for light less than 10 and rain between 15 and 20. If that's the case, it suggests potato. Every time a branch finishes, we use an endif block to close that decision and move back to the loop. This ensures our controller is constantly thinking and checking for climate changes every millisecond. Alright, let's do the working. Watch the OLED screen. First, I'm covering the light sensor to bring our light value down. Now watch what happens when I add just a few drops of water to our rain sensor. See that? As the moisture hits that perfect range, the screen immediately updates to temperate crop wheat. This logic allows a farmer to know exactly what fits the current climate data. If we change the condition slightly, the system recalculates. Now it's suggesting apple and potato. It's like having a digital agricultural expert right in your hand. This is the power of combining sensors with smart code. We aren't just building gadgets,
we're building solutions of farming. Excited to explore more? Register your child for our robotics and coding courses at Maker's Place. And don't forget to subscribe to our YouTube channel for more educational videos.